All right. Testing 1, 2, 3. Testing 1, 2, 3. Got a green circle there. That's good. Looks like we got some bars there. That's good. So it means we are broadcasting. We are live. Greetings, travelers. How are you? It has been a little while. I do apologize for that. But some work came up, and thanks to all the wind recently, my allergies basically knocked me on my butt, plus the work. I had to take a few days off of streaming. Sorry about that. We are back. Let's get rid of this. There we go. Oh god. Let's see. So there's our browser. Do we have our sandbox universe? There we go. And our planetarium? Yes. Yes. There we go. All right. So we got everything ready to go. We're not doing the full planetarium show today unless somebody actually wants us to. But, today is our news day, so if you haven't been paying attention, there's been a lot of things happening in astronomy. Really just the Mars-related stuff, so we'll be talking about that. Let's actually start with what we always start with. Get rid of you, get rid of you. And we're going to start off with astronomy picture of the day. Please try to start out with this. You can find this yourself. Just type in astronomy picture of the day in your favorite web browser, and it will come up. The APOD archive does go back to 1995, so some of the photos get smaller and smaller and less quality as you go back, but it is a large database. Every day a new video or picture or sometimes music, sometimes art. All depends. Most of the time it's photos, which is always good. So let's take a look at the last few days since we haven't broadcast in a while. We're just going to go take a look. Color over the Azores. That's cool. You see the Milky Way. Actually, this is really nice because some of them, as you can see, you can actually pan over and you will get explanation directly thrown right over it. If you don't know what you're looking at, there's always a description in the bottom, and then lots of links to either the people that took the image or made the animation, or locations and things like that. Like if you don't know what the Azores are, boom, you click it, there we go, Azores. Still very, very cool. That is the Milky Way right along this path right here, clearly labeled, which is, well, that's our home galaxy. We'll talk about galaxies and things as we go along. Galactic Center in infrared the next day. This was April 19th. So this is looking at the heart of our galaxy. Really beautiful photo. Usually you can click on them, make them a little bit bigger. Oh, delicious. That is just delicious. This is from the Spitzer Space Telescope. Looking in infrared, so that's light that our eyes cannot see. It's below our field of view for the most part. Bright reddish color coming likely from hydrogen gas floating in space. The darker regions, you're going to see some clouds of dust and gas right in here. Cooler dust and gas. Oh my god, we can zoom in even more. All the dots you see here, those are individual stars. And you'll notice the stars, of course, have different colors, and if you've seen our planetarium shows, we always talk about the fact that stars, of course, have different colors, which means different temperatures, which we can, of course, see based on their colors. Red being the redder, colder, red being redder. Very good. Professional here. Red being the older, colder, redder stars. Blue being the younger, shorter-lived, hotter stars. And of course, right here is the smack dab in the middle of our galaxy. We can't directly see it, but smack dab right in here, there's going to be a black hole with a huge accretion disk of material around it. That is the center of our galaxy. Very, very beautiful. You'll be able to see this if you're up tonight, around 2 in the morning or so. Summer sky is where you really want to be looking up at the south part of the sky to see the heart of our galaxy. Now, this is one of the topics that we are going to talk about today, is the Mars Ingenuity helicopter, which, you know, was dropped off from the Mars rover known as Perseverance, so it was on its belly, and then they did some testing, and there was a little bit of a software issue. They did a software upgrade, or a firmware upgrade, I guess would probably be the better way of describing it, and then they tried to do something fun, and they did this. Spin, little rotor, spin! This is actually imagery from the first flight, which was just a little bit off the ground. The fact is that it actually worked. They spun it around, landed it back down. Really, really cool. You are witnessing the first space flight, or unmanned aerial flight on a different planet. And that's really, really cool. They then followed it up, actually, hopefully we'll get video of that soon. They followed it up with another flight, which was even higher, and actually had the craft kind of tilting back and forth to, you know, prove that it actually could fly more than just flying straight up. So that opens a whole new world of possibilities when it comes to exploring Mars, or even exploring something. It's mentioned down here, the moon Titan. Titan is a moon around Saturn, which actually has an atmosphere. It's a very thick atmosphere made of methane, as opposed to the very thin carbon dioxide atmosphere of of the planet Mars. Which of course implies, you know, you could repurpose some of this technology, change things a little bit, and make sure that it could fly on Titan. Then you can actually have little drones flying around, studying more area for the same amount of time than you would with just a single rover or a single craft. All right, here we go. What do we got here? Centaurus A's warped magnetic fields. There's multiple different things. There's X-rays, there's infrared, all kinds of stuff right here. Looks like we have a galactic neighbor named Centaurus A. It's in the constellation Centaurus. And it is giving off X-rays. So it's actually a composite image. You've got visible light. What our eyes can normally see is going to be like this bluish color down here and all this stuff back here. And you see these jets. And if you've watched our shows before, we've talked about the jets before. The jets usually come out of the, let's say, north and south pole of a black hole, or you know, the spin axis of the black hole. And it looks like they've got all this extra stuff in here. Added in, so they're actually showing, you know, around where the accretion disk is, and you can see all the bending right in the middle here of the magnetic field lines. So instead of having magnetic field, most of the time magnetic fields kind of go from north to south, boom, boom, and call it a day. You make a little shell. These are a little more chaotic, as you can see. Well, howdy, how are you? Good to see you. Thanks for stopping by. We're just talking about random stuff like we normally do on Fridays. We're talking about the news. We just talked a little bit about the Mars Ingenuity rover. Helicopter, I should call it. A drone. Let's just be honest, it's a drone. This thing. We're talking about Astronomy Picture of the Day. So whatever fun things came up on Astronomy Picture of the Day, that's what we're talking about. Earth at twilight, always kind of cool, seeing what's called the Terminator. The line between bright and dark as sun begins to set. As our planet spins on its axis and goes from night to day. Always very cool. I want the archive. What do we got here? Yes, this one. Here we are looking at the Earth from the space station. Now here's what's interesting before we keep going. The constellation Orion is visible right over here. 3 stars in the belt. Bellatrix, Betelgeuse. See it rising up. See the Orion Nebula right in there. This, of course, is the Earth at night. You see the city lights. You see these, the Aurora Borealis, the northern and southern lights, for that matter. These, I believe, are the northern lights. And as you can see, the city lights of our planet, the cities, I should say, give off light. And that light causes our planet to glow at night. Looks like that's Florida. Yep, that's Florida upside down. Just gonna let it play and watch. That's lightning strikes from clouds, obviously. It's amazing the stuff we humans do, huh? Not as amazing as what nature does, but it is a thing we do. And that thing that we do is we make light. We try to light things up at night so we can still function and have society going. But that light pollution does cause a little bit of a problem. Let's see if we can switch over here. It does block our view of the nighttime sky, so let's actually get over here to the planet Earth. Let's slow it down. Stop it. There we go. So here you see the Earth at night in our simulation here. And this, of course, is looking at the north and south continent of America. Let's see, can we slow it down a little bit? It's spinning pretty fast. That's a little too slow. I broke it. There's the Earth at night, as we said. Hey, buddy. See Hawaii out in the ocean. Not too much light. This is why they put a lot of observatories there. There's not a lot of light pollution to bother this. Ideally, you are out here in the middle of the ocean to look at the sky, because there's very little, if any, light other than the stars themselves. Here we are looking at Asia and Southeast Asia. Again, you can pick out major cities just by looking at them if you know anything about their geography. So you got Tokyo there, got South Korea over here, got China here, Vietnam. Incoming, there's India. So this is kind of the same effect that we just saw in that video. And we're looking at the Earth at night. But again, there's a simulation, so here we can stop it and you can see, you can see the Nile River. And Dendera would be up here, and you got Cairo up front. Saqqara somewhere in here. Very, very cool. But once again, not ideal if you want to look at the nighttime sky if you're in these locations that are very, very light polluted. I'll replay this one more time so you can get an idea of what's going on. So here, this is from the space station flying over, I believe, the United States, because it ends up at Florida, so flying from the northern part of the United States downwards, so I think that's California. Flying over the Rocky Mountains. across the United States. See that? Clouds of the atmosphere causing some blurring and distortion. That's most definitely Florida. Florida Keys. So yeah, real. This is actually real. What we looked at before, that's a simulation in our sandbox universe, but this is real footage. There you see lightning strikes once again. Really, really cool. So yes, as always, every Friday we always start off by doing news segments. We talk about whatever's new, whatever's happened over the last week or so in astronomy, and that's kind of the cool thing, is that there's always something new happening, something new getting launched, new data being reviewed or discovered. We always start off with astronomy picture of the day, just because, again, it's a nice thing to start out with. There's always something new to talk about every single day. We also always start with talking about the Solar and Heliospheric Observatory. Now, the SOHO, as it is called, is an observatory in space. It does look at the sun. Now, I do not recommend you ever stare at the sun unless you really want to hurt your eyes. Coming back to our planetarium, this is actually what the sky looks like outside right now. We have clouds here, but in our planetarium there are no clouds. You see the sun smack dab in the middle of the southern part of the sky. Sun rises in the east, so the east is over here. There's an E. Sun rises in the east and sets in the west to our right. Got some new music going on, so always very cool to find new things. But the sun is not a static image. If I zoom in on this, it's going to look... Well, number one, don't do this. But number two, they're going to have some artificially inserted sunspots and things like that. This is not what the sun looks like currently. And so, I wanted to show off what the sun looked like. So, let's go to our other software. And by other software, I mean actually just straight up the web browser. To this, the Solar and Heliospheric Observatory. So, SOHO. It's a joke. There are some cold areas of the sun called sunspots, and here's actually a picture from today. Let's zoom in a little bit and let's get some orientation here. So you see the Earth is marked right down here, and then Jupiter is the larger circle down here. The Earth is about the size of my mouse pointer. And you'll see there's a sunspot over here, sunspot over there, sunspot over there. They're finally beginning to form once again. The sun goes through a cycle of activity. Sometimes the sun is really, really active and there's huge black splotches all across its surface. Those are sunspots once again. They are areas that are cooler and highly magnetic, and the magnetism causes material to not be sucked back down into the sun itself. The sun actually kind of looks like a boiling... Let's see if I can get a better picture here. So should have... That's the wrong place to go. You can see the sun looks like things are kind of bubbling up to its surface and then cooling off. There we go. Oh, we got a dead pixel or something going on here. That's unfortunate. But this is, again, looking at the sun the way it is right now. What's this from today, I think? Yep, this is from the day. Perfect. So, the sunspots that we saw before, you'll notice that in this image, they appear very bright. There's actually a lot of activity around sunspots. And so, that's what makes them very interesting. They are highly magnetic, so you'll notice these huge loops of material. We call them solar flares. They'll actually be pulling material off. There's actually a big one, big loop over here. There's filaments, there's solar flares, and then there's the really big ones, what we call coronal mass ejections, CME. And those are the more intriguing ones. Let's keep looking at the sun real fast. Here's, again, what the sun looks like, more like what our eyes would be used to seeing if you were able to look at the sun. It would look more yellowish, like this. And there again, you see the sunspots. Right along here, they're Earth-sized, so they're as big as our whole dang planet. Never a good thing to fall into a sunspot, because it would not be pleasant. However, again, remember, they are slightly cooler than the rest of the surface. The sun's surface, it's about 10,000 degrees Fahrenheit. It's about 5,800 degrees Celsius. Not a fun place to stand. Sunspots are going to be 2,000 to 3,000 degrees cooler, but still really hot for a human, so obviously you can't just, like, go and step on it. That would be a really, really dumb idea. This is a magnetic image of the sun, and what you see is where the sunspots are, you've got positive and negative magnetic field lines all twisted up. Let's see if we can zoom in a little bit more. Yeah, you can kind of see there's lots of different regions where this is happening. So some of these areas where stuff's being pulled up to the surface, some of it's where it's being pushed back down through convection. But again, the sunspots themselves, very, very active locations. Let's zoom back out. Actually, let's take a quick peek at this. Let's zoom away from the Earth. And again, don't stare at the sun, but in our software we can kind of take a look at the sun up close like this. As you can see, the sun is a yellow ball of plasma and gases. If I put it into motion, you'll see kind of that bubbling that I'm talking about. Again, there's a simulation. All these little, like, names you see, that's just stuff in the background. I can't really get rid of it without deleting a lot of things. Guess I really could do that if I wanted to, but I'm not gonna. Nonetheless, this is the sun. You see on this particular software there are no sunspots. In certain areas you see this little bubbling here. If you put a sunspot here, the bubbling would stop and so it would start to cool off. The magnetic field lines will get really twisted up, and again you get solar flares happening from these locations. Coming back to Soho, you can see there's lots of different colored images. Some of them show things a little more distinctly than others. Here again, the same sunspot regions, but you see lots and lots of activity. The magnetic field lines highly prevalent as the material gets pulled from one section to the other, making these beautiful, beautiful loops along the surface of the sun. Got a little filament popping off right down here. Now, onto the mass ejections. If you zoom out far enough, then Soho actually has a filter on it that blocks out the sun. The filter is represented by the dark circle. The white circle represents the physical surface of the sun. Sometimes you see planets in the image when you get zoomed out like this. But what we see here is actually material being jetted from the surface of the sun out into space. We call them coronal mass ejections. As you can see here, we do have a couple of planets, got Venus and I believe Mercury in this image. On the left-hand side, looks like there are some artifacts going on, so it looks kind of funky. But what again is really cool is you see all this material being blown out into space. This is what causes the aurora borealis. We saw the northern lights in that last video that we saw of the space station flying over the planet Earth. Well, this is part of the reason why those things occur. All this material, all this energy hits the upper and upper atmosphere of our planet at the North and South Pole. Travels through the Van Allen belts. I can speak today, I swear. The Van Allen belts, radiation belt of our planet caused by our own magnetic field. It accelerates all of this material, and then that crashes into the upper atmosphere of our planet, and it excites the... Come on. It excites the upper atmosphere itself. There's actually a really cool... There we go. From the other day, they uploaded this. This is actually what a coronal mass ejection looks like. They actually have material being blown off from the surface of the sun. You got Mercury on the bottom right there. But yeah, that's what you don't want heading directly towards us. That's what causes, again, it does cause the northern lights, but it also can cause some issues. Satellite communications. Can cause power outages at the extreme north and south of our planet. All depends. But yes, this is actually literally material being blown out. You can see it's about the size of the sun itself, so these are huge explosions. Still very, very awesome to see. Solar Hemisphere Observatory, it's been up there for about 25 years. Feel free to check out their website. They have a Twitter page. Lots of cool stuff always being uploaded. Actually can watch the dynamics of our sun over time, as you can see. You can see very, very distinctly when the sun is very active and when the sun is very quiet in an image like this. The brighter splotches you see here are actually going to be the areas where the sunspots are. So that's actually physically darker for our eyes, but in this particular imaging software, imaging package, I should say, sunspots appear very, very bright. So you can see very quiet, gets very active, and then quiet, and then active, and then quiet. Right now we're going through a quiet phase. We'll be getting more and more active as we go along. So sunspots will be picking up much more activity. Very, very interesting things coming over the next few years from our sun. The sun has about 5 billion years of fuel left in its fuel tank. It's fusing hydrogen into helium in its core. So, don't worry too much about our sun. Now, interesting, let's actually take a look at this. The sun is not all that big. This is an empty space. We're just, just a camera floating in virtual space. We're going to add the sun. This is something we usually do during our planetarium shows, but since we're talking about the sun, I feel we should talk about this. There's our sun. Our sun is an average star. We consider it a yellow dwarf star. There are some stars that are smaller. If you're a Star Trek fan, you know of Wolf 359. Wolf 359, of course, huge battle in the Star Trek universe with the Borg. Wolf 359, nope, that's the wrong one. Wolf 359's over here. There we go. You can see this is a red dwarf. Red dwarf stars, not very bright, not very big, very distinct, kind of a reddish-orange color to them. And as you can see, I did kind of put it kind of far away from the sun, but as you can see, it's pretty small comparatively. I guess, let me see if I can get it closer. Let's delete it. Delete it. Goodbye. I love you, but goodbye. Let's try again. Let's put it a little bit closer to get a better comparison. There we go. That's a little bit better. Look at that. You see, the sun... Oh, God, I just kicked my microphone. I apologize. The sun and Wolf 359. Okay. Let's see what else we got. Let's put in Sirius. Sirius is the dog star. It is the brightest star at night, and as you can see, it is really bright. As we've now put it in our planetarium, you see, or in our observatory thing here, our astral observatory, that's what we're going for. You see, the sun is only slightly smaller than Sirius, but Sirius is very, very bright. Blue stars are hotter and brighter than the sun. They don't live as long, because, of course, they are fusing hydrogen to helium at a much faster rate. They live by the live fast, die young principle. Never good. So why are we doing this? Well, I wanted to show you again the difference between stars. Small red dwarf star, average yellow star, somewhat average blue star. Now, Sirius, again, looks really bright in the sky because it's fairly close to us compared. It's not even all that big of a star. Let's look at Spica. Spica is another blue star, but you see Spica is physically bigger than Sirius. Spica is a star you can see tonight. It's in the constellation Virgo. There's the other one, Rigel. This is a blue giant star. Look at that. Compared to the sun, okay, the sun's still right here. Got Wolf 359. Look at that. Our sun is tiny compared to these much larger stars. Now, we're going to talk about giant stars. Stars, when they get older, they stop fusing hydrogen into helium, and they begin to fuse, or they try to fuse helium into other elements. They then puff up to try to keep pressure going. Stars are just big furnaces. There we go. Oh, God, that's not what I wanted. Womp womp. Let's add this star in. Let's look at Antares, the heart of Scorpio. This is a red giant star. Now, remember, the sun is still here. The sun is still in this simulation. It's right there. But compared to all these other stars, you start to notice the sun's really small. Red giant stars are physically ginormous. They are huge, huge stars. There's Betelgeuse, or Betelgeuse, the armpit of Orion, the shoulder star you can see tonight, big bright red star. Where are my supergiants? Nope, that's not what I wanted. There they are. There are some red giants that are even bigger. Look at that. The largest stars that we know of. This is VY Canis Majoris. No. Yes. And then UI Scuti, I believe, is the largest star we know of. There we go. Look at all these giant stars. These things are huge. These are stars nearing the end of their lifetime. They're going to explode one way or another. Way down here is our sun. Interestingly, these stars likely have the same kind of patterns. You still have solar... you have sunspots, you have solar flares, but on these other stars, they must be gigantic. So there's a good example of what's going on in space. Stars of different sizes. If I put this in motion, bad things will rapidly occur, as these stars are going to collide. This has nothing to do with actually what's going on in space, but hey, we got a simulation. We can blow things up. This is stellar collisions, supernovae in this respect. So we're going to blow some stars up. Kaboom. Lots of radiation, terrible things happening. Ugh, there went another one. So we're going to zoom back out. They're just going to keep exploding as we go along, and as I keep zooming out because I don't want the computer to, like, freak out and die. Anyway, just figured I'd do that as an aside. That's why we have this planetarium software, and this... Actually, this particular one is a video game. This is Universe Sandbox, which you can get off of Steam or GOG, or you can directly buy it from them. The planetarium software is this one. This is Stellarium, which we'll pop into back and forth as needed. So we talked about Ingenuity. It did log its second flight on Mars. We looked at the first flight earlier. I believe this is the second flight footage. Yeah, as you can see, they got it up into the sky, twisted it around. I believe they tilted it a little bit. Not bad for a little drone, right? Now, think about this. This means that future missions to Mars, you wouldn't necessarily have to create a rover. You could create a home base filled with these little drones. You land it on the surface of the planet, and then these little drones can be launched one at a time. They fly around, and then they come back to home base, land, charge. Interestingly, you could hypothetically do that without having a solar panel on the craft. You put all the solar panels and all the charging stuff, or if you preferably use nuclear, because there's lots of wind on Mars. Unless you make some sort of way to make sure you keep the solar panels clean, the dust will actually eventually cover up the solar panels and reduce the charging rate of the panels themselves. But you could hypothetically create like a little base and have little drones flying around the planet Mars. Instead of driving a rover around one at a time, you could have multiple teams flying multiple aircraft drones like this around the planet Mars. Now, you can't necessarily go and, dig up rocks or, laser into rocks like you can with a rover, but you can cover a lot more area from the sky in a lot shorter time period. So it'll be interesting to see how they incorporate using aircraft like this in the future. There's a cool look at the surface. Looks like a crazy bug. And of course, the other really interesting news that came from Mars was this. If you missed it, this was reported a couple days ago. there's some equipment on board, and using this equipment, they brought in a bunch of the carbon dioxide from the Martian atmosphere, ran it through the equipment, some sort of catalyst occurs, not cataclysm, nothing exploded. There's some sort of catalyst inside of the equipment, which causes a chemical reaction to occur, and we have the first time oxygen has ever been created by us on the planet Mars. That's really, really cool. The instrument is called MOXIE, which I think that's a great name because it's got some moxie to it. Mars Oxygen In Situ Resource Utilization Experiment. The whole point of this is to see, you know, if they have the right equipment and if it fully functions, can they convert some of the carbon dioxide in the atmosphere into oxygen, making breathable oxygen? That means there's less of a need to bring oxygen from the planet Earth to the planet Mars if you were ever to do a manned space flight and, you know, try to make a base on the planet Mars or some sort of, you know, Martian outpost. Well, you're going to need oxygen for people to live, and there's only so much you can take with you from here, so you got to be able to make it while you're there. Being able to pull from the atmosphere and creating actual oxygen is a really, really interesting experiment, and obviously they'd need to scale this up for the level that people would need. Produced a total of 5 grams of oxygen. Woo! After a 2-hour warm-up period, MOXIE began producing oxygen at a rate of 6 grams an hour. That's not a lot. But the point is, it worked. So you scale this up, and now you know about how long it takes for you to create oxygen. Looks like this 5.4 grams is enough to keep an astronaut healthy for about 10 minutes of activity. So again, that's not a lot. But these are all experiments to test equipment and to test technology so that when they scale this up, they'll be able to produce enough to help, you know, keep a person alive for a few hours in just a few minutes. It's really, really cool. What other fun news happened this week? We talked about Mars, looked at the sun. Oh yeah, this happened, didn't it? The Crew 1, which we talked about a few months ago when they launched from Earth to Mars on SpaceX's first manned flight to the space station. They came back down from the space station, and they are going to be replaced by Crew 2. Fun how that works. Just change the number from 1 to 2. This was the launch. I actually did attempt to stay up and watch this morning, and I was going to live stream it so that we could all watch it together. And then the internet went out at our home office. So I had to watch it on my cell phone, which is fine. It still means I could watch it. But this was the launch of SpaceX Dragon, Crew Dragon. That's the official name of it. This is Crew 2. They are on their way to the space station. Should be docking soon. Around 5 in the morning, looks like, on Saturday morning. So that's about 3 a.m. for me here. But yes, if you missed the SpaceX launch, right now the launches are at 2 or 3 in the morning, so it is not the best for people that have to be up early, or if you're, you know, just into beauty sleep and things like that. Watching a space launch like this, maybe not the best for you. But it did happen this morning, so good luck to all the astronauts. There were actually 2 astronauts from NASA on board, one from the European Space Agency. I believe he's a French astronomer, astronaut, I should say, and another Japanese astronaut. Good luck to them all. Can't wait to see what they do once they get there. No video. I was actually looking for the video. I had to watch a replay this morning, but it is what it is. Other launches. This is actually something, again, we talk about the news, not just from NASA, but from around the world. There was a launch from the Chinese Space Agency. I believe it's called Xi'an 6. But it was launched on April 7th, and we're just barely finding out about this now, so it's okay. But yeah, got a bunch of satellites. Polar orbits, by the way, are really hard to do. Just the math involved in getting things in polar orbit, not very easy. So good luck to them to get these things in proper orbit. Getting in orbit around the equator far easier. That's actually why if you look at the planet Mars, if you ever look at a map of where we've landed on the planet Mars with various rovers. Let's see, can we get to Mars? There we go. Let's slow this down a little bit. Boom. You'll notice when we look at a planet Mars, a lot of the at the planet Mars, a lot of times we're landing within what we would call the equatorial zones. On the Earth, you would call them, you know, the Tropic of Cancer and the Tropic of Capricorn. Well, it's the same idea on Mars. It's just, it's easier to land. The math is a lot easier to get stuff to land along these regions in the middle than it is to land at the North or South Pole, as well as entering into orbit. Since we're at Mars, I guess I should talk about this planet, but we're going to do it in an empty zone. So let's get rid of all this. Hello, hello, hello. I do see some new people there. How are you? Hope you're doing well. Thanks for stopping by. We're just talking about the news of the week and kind of screwing around with our software here. So let's add Mars in. This is the planet Mars. And Mars does have 2 satellites or moons orbiting around it. So let's add them in. There they are. Very good. Now, the planet Mars, it holds so much interest for us because, well, in some odd ways, it kind of resembles the Earth on a smaller scale. So what do I mean by that? Well, Mars has a 24-hour, 37-minute long day. It's called a sol, so it's a little bit longer than an Earth day, but the planet itself is about half the size of the Earth. Actually, I think we can show you that here if you really want to. Let's take the Earth. We're just going to put it right here so you can see. There you go. Mars is about half the size of the Earth. Give or take. A little bit less. Mars has a tilt like our planet Earth, so its North Pole is not vertical. It's actually tilted over slightly. About the same way as our planet Earth is. And so it also has seasons. You'll also notice down here there's some whiteness going on. There's actually ice caps at the North and South Pole of the planet Mars. However, they're made of dry ice, carbon dioxide, frozen into solid surfaces. There is evidence that there's liquid water, or at least frozen water, at the ice caps, and there may have been liquid water on the surface in the past. That's why we kind of keep studying the planet as much as we do. Waiting for a region called Tharsis and a region called Valles Marineris, the Mariner Valley. That's this huge crack right here. This would stretch across the entire United States if you were to bring it here. And these shield volcanoes here are extinct. There is no volcanism. There may be quakes still happening on the planet Mars. No one's really truly sure what the internal dynamo of the planet is. There's no lava flowing under the surface. There's no tectonic plate activity, so how are there earthquakes? No one's really sure. Olympus Mons, Mount Olympus, about 650 kilometers. This huge, huge volcano right over here. If you looked at the map of the United States, this would cover up an entire state in the Four Corners region, so Arizona, New Mexico, Utah, or Colorado. Pick one. This would take up the whole entire state. With its moons, we got Phobos and Deimos, Fear, and Panic. You'll see they're kind of asteroids that have been captured into orbit from the asteroid belt. If we go back to our other... Now, these are not rings, that's just the path of these moons. If we go back to our other simulation, you'll see Mars is closer to the asteroid belt. Mars represented by the red circle, red ellipse, I should say here. You see all these asteroids out here, so at some point it's likely a couple of asteroids strayed, got caught by Mars's gravitational pull, and became Martian satellites, or moons, as we call them. But yeah, that's why polar orbits are hard, the math is hard, and China's trying it, so good luck to them. Other thing, this coming week, the full moon should be on the 28th. The moon, as it orbits around our planet Earth, we'll look at the moon here in a second. As the moon orbits around our planet Earth, it does change its phases. We normally talk about this during our planetarium shows. But here, as you see, as the moon orbits around, different amounts of light is reflected back towards us here on the Earth. Right side and the right side, we call it a waxing moon. It goes from waxing crescent to first quarter when it's gone 1/4 of the way around our planet. And then we'll skip on past that to what's called a gibbous phase. Not a crescent anymore, but it's also not full. That's where we're at right now. And on the 28th, we'll get to full moon, which means the sun will set, the moon will rise at the exact same time. This is the pink moon. This month is called the pink moon. It's not actually going to be pink. There's full moon right there. The full moon is named after different things depending on the month. There's a harvest moon, there's a wolf moon, there's a pink moon, which is this month, there's a snow moon. It's a salmon moon. All depends on various things, you know, what's happening around that time of year. Obviously, the snow moon's going to be during the winter. Pink moon is actually when you start to see pink phlox, a type of moss, start to grow because it's springtime. After the full moon, you go in reverse with the phases, so you have waning gibbous into a waning crescent. But before you get into the crescent phase, you have to stop at third quarter, which is right here, 3/4 of the way around our planet. Into waning crescent, and then back over to new moon. New moon, of course, when the bright side is on the back side, the far side, the dark side of the moon. There is no dark side of the moon. Just turns out that's the back side of the moon that we don't actually get to see very often from here on the planet Earth. Get a good look at it in our simulation here. Earth and moon. There's the Earth. There's the moon's orbit. Notice it's not exactly circular. It's our beautiful moon. The darker regions on the surface, they call them the seas or the mare of the moon. There's supposedly, depending on in Western, I guess, mythologies we'd call it, you can kind of see a man on the moon. So you got a head right here, you got a nose, you got a chest, fist, and a wrist down here, another fist, a belt line. In Eastern mythologies, particularly with Chinese mythology, you have the jade rabbit on the moon. Do you have to rotate the moon? You have to kind of tilt your head to see the bunny rabbit. I rarely am able to kind of pick it out, but there is supposedly a rabbit on the moon. And of course, they have the lunar deity Chang'e, and she lives on the moon as well. Now, if you've never seen the backside of the moon, again, we talk about this during our planetarium shows. But we're going to go ahead and rotate this. You'll see the Earth, if we zoom back out, you'll see the Earth is rotating fairly fast over there. We're going to be watching the moon itself. We're going to be orbiting around the moon. There we go. So as the moon orbits around the planet Earth, there's again a different amount of light reflected back towards us. This is the back side of the moon. This is the side we do not get to see from the planet Earth because, well, the moon is tidally locked, which means gravity over time has kind of locked it in place. Excuse me. It has locked it in place with the backside facing away from us for all the time. The only way to see this is in a simulation, which we know of all this data by putting probes around the moon or by sending humans to the moon as well. This is our only natural satellite. It does cause tides here on the Earth based on its gravity. As you can see, this is the beautiful dance that we have with our moon. A day on the Earth is 24 Earth hours. A day on the moon is about 28.5, 29 Earth days. Very cool. And that's pretty much it. Fridays are really, really laid-back days. We just kind of hang out, talk about whatever was new and interesting for the week, and if there's, you know, questions and stuff, we sit around and talk about it. But it looks like it's kind of slim pickings. It's Friday. Everybody's kind of ready to go home. That's all right. So that's it. That's our 3 o'clock hangout. Drink some coffee, drink some tea. Today we had some tea. So we hope you enjoyed learning a little bit about what's going on in space news for the week. If you have any questions, feel free to ask them in chat, or you can stop by our Facebook page or over on our YouTube page as well. All of them named Earthshine Education. We are on Twitter, we are on Instagram. Follow us on all of your social medias. Giant worldwide dance party, obviously. Have a good, safe weekend. We'll be back on Monday to do some planetarium shows and more general astronomy. Hopefully by then, these allergies will go away and I'll be able to do a show without constantly having to pause my voice. With that, we end our stream for the day. Hope you had a good time. Good to see those of you that popped in. We did get a new follow, but that was actually off stream, oddly enough. So, Haruki Kai, thank you for the follow. We do appreciate that. We are trying to get some more viewers, so if we can start sharing this around just so we can get more viewers during our broadcast, that'd be great. We are right on the cusp of being offered affiliate status, which would be an incredible feat for us. So, please have yourselves a wonderful afternoon, evening, morning, wherever you happen to be. Please take care of yourselves, take care of each other. May you have clear skies. We'll see you on Monday.